My name is Rob and I'm building a hypercar. In order to make parts for our hypercar, we need molds and plugs. Molds to hold the shapes and plugs for the inside. And we could get those manufactured, somewhere externally, have that done, but that takes forever and costs a lot of money. So in order to control all of the manufacturing ourselves, we need a way to make plugs and molds. Today we're going to start the construction and build of our CNC-based gantry mill. And we're building that so we can make the molds and the plugs needed to build our composite parts. We're building a car, and a car is big, so we need a big machine to do that. So that's why we're starting with a large table and building something pretty good size. So our table is 90 centimeters wide and 181 centimeters long. So why did I pick this size table? Well, simply because it was available. This is a leftover from some lab here in the area. It's a very stable table. I've seen a few of them for sale. You could obviously use a welding table for this. I think this is an optical testing table, but something really sturdy is what you need. And this one happened to be available for a very good price. So what we're planning to cut on here is high density foam, HPE to be exact. And those come in blocks of 610 millimeters by 610 millimeters by 1220 millimeters, or for the Americans among us, 2 feet by 2 feet by 4 feet long. I want to be able to fit one of those blocks on this table and be able to carve it out in one go. When all is said and done, we'll have a 4-axis CNC table, for those of you that know what that means. But let me explain to you the first 3 axes. So the first one is the x-axis. That's the long way across the table. And there'll be a gantry, that's why it's called a gantry mill, where this is the first part, the mock-up, and it will slide all the way along the length of the table. Right now, because there's only one side, it's not very stable, but it will get there when we put it together. Second part is it will be going forwards and backwards. So there will be a carriage that slides from left to right. That's the y-axis. And then, you may have guessed, there's the z-axis. And the z-axis is up and down. So in this case, that movement. And while this is just a mock-up, so to see if all the sizes fit, you can see several things here. We've got rails here and there. So one in the horizontal plane, one on the vertical plane, with carriages that the whole carriage will run on. In the middle, there's a ball screw, and that will make sure that the movement happens and that the rotating movement of the motors is transferred to linear movement that will make the carriage run. That same construction will be on the other side. In any type of computer controlled machine, like this is going to be, that's what the CNC stands for, computer numerical controlled, there's 2 aspects that are very important. That's precision and repeatability. Well, we're going to get that by making the movement happen in ball screws. So this screw will turn, and this nut, which is a really fancy nut with bearings in it, will twist and will move along with how you turn the ball screw. We're moving that ball screw using very precise motors, in this case stepper motors. And these are very strong, very heavy motors, and these can do 200 steps per revolution. So we can very precisely tune how much we turn that ball screw and then how much that nut moves. And that's how we're going to make sure that the machine is very precise in movement, but also very repeatable. We can always go back to that same position. So besides the 2 aspects of movement, so precision and repeatability, there's a third aspect that's really important in these machines, and that's rigidity. And you know anything about the construction of these machines and what I've built here, this is not going to be very rigid. It's going to be very precise, but it's not going to be very rigid. And why doesn't it have to be very rigid? Well, I'm not planning to cut any hard materials on this. The intent here is to cut foam, very soft and easy to cut. So we don't need a lot of rigidity in the machine to be able to handle that. There's another aspect that makes the rigidity less important. It's speed. This is not going to be the fastest machine ever. It's actually going to be relatively slow, but that's okay for what we're doing. Because for speed, we also would need rigidity. And if we want all of those aspects, precision, rigidity, and speed, well, price goes up. And we're trying to do things on a budget here. To make sure we get the best performance possible, we have 2 ball screws on the x-axis, so on both sides, long ones, they're about 6 feet long. We'll have 2 ball screws on the z side, so left and right, and there'll be 1 on the y-axis. And all of those will be on 2 or 4 individual rails. And if you look at the ones that we have here for the y-axis, they're the same as the one on the z-axis. They're actually 20mm solid steel ground rod. These are very stiff, very rigid. For this kind of distance, there won't be any movement. As a cutter for now, I'm using a regular router just from the do-it-yourself store, nothing very special. It's going to be mounted right here and then move along on the X, the Y and the Z axis. As a cutter of these, we'll be using 1.6mm, an 1/8 of an inch cutting tools. They're tiny and they're very sharp. They spin at a really high rate of speed and they will be able to shape the material. This one's got a pretty long cutting head, so we can actually cut pretty deep in the foam. And if we want to, I can actually put much bigger cutters in here, up to a 2-inch diameter, if we want to cut really quickly and want to remove a lot of material. But to make it a little bit more visual, to make it a little bit more easy to understand what we're trying to do, we've placed some foam. These are all loose pieces, but it gives you an idea. On the machine, this is how it would work. The spindle would sit right there and then move forwards, backwards, left, right, up and down with that cutter in there and cut the foam to the desired shape. This is soft foam, so it won't work very well. What we'll be using is very stiff foam. So this table has a big advantage. It's really rigid, that's the first big advantage, but it's got a really nice layout every 2 inches of a 6mm hole. And don't ask me why it's every 2 inches with a metric hole, but that's what it is. That will allow me to really fasten all the materials that we're going to be cutting onto the table really flat and really rigidly. In order to do that, I 3D printed some work holders. So let me show you what we can do with those. So using this work holding, I can really quickly and very solidly mount materials and make it repeatable. It's always in the same place. So that makes making multiple parts that maybe have to be cut from different directions or multiple the same parts very easy. By now you've probably already guessed that this is not a 1-episode build. This is going to take probably about 5 videos, quite a bit, because there's many aspects of this machine that we are going to have to build. On top of the mechanics, the electronics, there's the computer controls, the CNC part of this build. For that, we've got this big electronics cabinet that's sitting on the table in front of me. It will be mounted on the base of the table once we're done, but for now, this is where it's at. There's many components in there. What we have here is the power supplies, 24 and 12 volts, relays, fuses, stepper drivers, and the main control board. There'll be a few other elements in here, but those are the big ones. There'll be a separate episode just to focus on the electronics and the electric side of it. So this is the mock-up, and as you have been able to see, these are the parts that we still need to attach. Next episode, we're going to take the mock-up apart, manufacture the parts that go in between, lots of 3D printing I'm expecting, and then put everything together so it's mechanically finished. See you then, and obviously if you like this, please like, subscribe, comment, and even better, tell your friends about us. You'd really help us out. So like everything we do here, the autoclave and now this, everything we're building, all the parts, everything we've designed, we'll make sure it's on the website and you can download it from GitHub. The link will be under the video.